is Eva Cernadas from CiTIUS, the Centro de Investigación en Tecnoloxías Intelixentes, the Universidad de Santiago Compostela, and we'll speak on computer vision and machine learning change the way in which biomedical researchers analyze microscopic images. I'll take the opportunity to just tell you some information. We have a change in our program. Graziella Pellegrini, the speaker after this one, will not be able to show the work. So we have some more time also to explore some possibilities with Eva Cernadas, and she will also present some interesting analysis of histology.
Okay. Good afternoon. This research is made with the computer science researchers and biomedical research. All people know that microscopic imaging has a prominent role in life science and medical research because it provides details about the cellular morphology. But biological researchers many times use this information in a qualitative and descriptive way. Instead of the useful information that provide quantitative analysis, it is very rarely made. Because manual quantification is very time-consuming and requires specialized personnel, and many times is very subjective. The most popular software used to quantify analysis is ImageJ, but I think the ImageJ have some drawbacks. The main drawbacks is that they provide automatic analysis, but many times this analysis is not adequate for the biomedical researchers. And otherwise, you need to know programming skills to define new macros. Our investigation tries to combine the automatic processing of the image with a useful graphical user interface, a friendly graphical user interface, to supervise the automatic analysis before the quantification, and stop all the information in different kinds of XML files or CSV files. I am going to show some successful stories of using this kind of software. One of the software is CiTIUS Analyzer, which is used to quantify the cystic index in a histological image of cystic liver or cystic kidney to the studies of polycystosis disease. This is a screenshot about the application. Afterwards, I am going to show a software operating. For example, this software is used in the nephrology laboratory of the Santiago de Compostela Hospital since February 28. This is an example. For example, this is the detection, the recognition provided by CiTIUS Analyzer automatically. And it recognizes quite nice the cysts, which are the white areas, but sometimes some areas are erroneously detected. The user can supervise this detection and remove the incorrect regions. This is the detection provided by ImageJ, in which the white regions are considered as cysts and the black regions are considered as background, but many white regions are erroneously. And then the quantification of cyst index is quite bad. We analyze 128 images of kidney and 287 images of liver, divided and grouped in 3 times: middle cystic, cystic, and severely cystic. And we compare the results obtained by ImageJ, the CiTIUS Analyzer after supervised by expert, and the CiTIUS Analyzer automatically. And the results are that the difference is not significant for a very severely cystic group to liver and to kidney, but the difference is significant to cystic and middle cystic groups. As well, the software is adapted to the problem of quantify fat index in histological image of liver using hematoxylina eosin or oil red stain standard protocols in order to evaluate obesity mechanisms. As well, the interface is quite similar, but the right panel is specific for each problem. This is the detection of the fat regions, and for oil red, this is the detection of fat region as well. This software is as well working in the daily work in the molecular metabolism lab in CiTIUS in Santiago de Compostela. And for liver analyzer, here we can quantify the number of fat regions which are correctly detected, which are higher than 97%. And here is the difference in fat index calculated after expert supervision, the blue line, and before expert supervision automatically is the green line. And we can see that the difference is very narrow. The future will be to extend this system, this software tool, to other applications in which you need to count and measure different objects of interest. This is, for example, for fluorescence images of brain, or to quantify images from the transmission electron microscopic. Now I am going to show the software. It's a software which works in a laptop computer. Here is, for example, an image of liver, and then we apply RUN. It's very fast because an image of 3 million by 4 million pixels can analyze in very short time. And we can say, oh, this is not a cyst. Then I select the cyst and I can remove. Or I say, oh, here is a cyst. Then I select the pencil and draw another region. Afterwards, I can show the cystic index, which is the black, the area occupied by cyst, and the number of cysts. And as well, I can show a table with all the cysts and say this is this cyst or this cyst. Or as well, I can select a cyst and say the diameter and the area. This is, for example, a kidney image, and as well I select image kidney and say RUN, and detect all the cysts. This is not detected, maybe because I set the mean diameter and maximum diameter of the objects to detect, and maybe this is a cystic higher than 100 pixels. And then maybe I can say the biggest cyst is this one, and RUN again. And in this time, this cyst is detected. The results can be exported to CBS files. Exit, and there is, for example, this is liver analyzer. As well, I have an image. The interface is very similar, but the right panel is different for both applications. And say RUN and detect all the cells. As well, I can check and say this is not good and remove. Or I can load oil image as well, are very different, and say room. The color is not so good. Maybe I can change the colors and put the color as a little more. Okay. That is all the regions. And any more. Thanks for your attention.
Floor is open for questions. One question.
What kind of supervised learning is that? Neural network or some KNN?
To the recognition of the system, the objects are quite classical computer vision techniques, because the images are very high, the dimension of the image are very high, and then we need very fast techniques to do online.
Have you tried the TSNews?
Sorry?
Have you tried TSNews?
No.
TSNE? No. Have you also tried to classify if it is true, positive?
No,
true?
because in this technique, in these two applications, we don't need to classify the objects. We only need to recognize the objects, and then no classifiers are used.
Okay, thank you very much.
Okay. Any other question? We have time. We have time for questions, because the next speaker is not here. So,
I'm sorry if I missed a bit of the talk, but I'm particularly interested and excited about your software. You showed some fluorescence images, so you probably did some analysis on the fluorescence images. So, do you think it performs well, or what? Do you see any limitations with the images that have a range of intensity rather than a positive-negative criteria for the analysis?
We have some software with fluorescence images, but it's not tested at the moment statistically in the lab. Right. And then I don't know, as I a computer vision researcher, I don't know the number of times of images that could be in medicine. I say, you say me, I have to recognize this object in the image, and I say, I can do or not can do, but I don't know the vocabulary of the meaning of the medical things.
Yeah, sure.
Yeah.
I'll look for you and we'll have a brief chat.
And then we have some two applications of fluorescence images. Mm-hmm. One is breast tissue, right. And this show here is from the brain images. But I know exactly is in the neuroscience research, but I don't know exactly.
Even there on that sort of images, you're detecting like
there are cells.
The irregular shape of fluorescence events, just for instance, everything that is green, and then if you have different ranges of green or intensities of the green, do you think it behaves?
Normally, I don't use intensity technique, right. Because the intensity technique are very sensible, yeah. To the image acquisition. Mm-hmm. I normally use spatial techniques.
Yeah. Thank you very much.
Any further question? If not, let's thank again our speaker. And let's move